All right. So after addition, subtraction, and multiplication of polynomials, we are now ready to look at division. Yay! So the first rule that we are going to look at is what they call the quotient rule. And the quotient rule applies for something like this, where I have a variable raised to a power divided by the same variable raised by some other potential power. The best way how to remember this is by thinking about it like this. Top minus bottom. And before you put the exponents in, you always start by placing the parentheses first. This will be very important later on when the examples are getting more complicated. So let's have a look at the first example right here. We have x raised to the 7th power and we want to divide it by x raised to the 2nd power. So what this is turning into is I have x, I'm going to say top minus bottom, and the exponent in the top is 7, the exponent in the bottom is 2. And that will be then x raised to the 7 minus 2 is 5. Okay, and that was it. Now, some people are still thinking about it in this way, and you can technically x raised to the 7th power. Well, that means x times x times x times x times x. Do I have 7? No, one more. All right, and on the bottom, I have 2 factors of x. Now, this is all multiplication. So, strictly speaking, common factors cancel out. So, you could just cancel out 2 of those factors, and I have exactly 5 factors left of x in the numerator. This way of thinking only works, though, if those numbers up here in your exponent are nice. So, the safest way to do is by still thinking top minus bottom right here. Okay? Let's do something else. We have another rule. What happens when I have a 0 inside my exponent? So in other words, if the exponent right here is equal to 0, that will be positive 1. If you have any real number, yes, lo and behold, in college algebra we will be looking at numbers that are not real. Don't be scared. But other than 0, 0 to the 0 power is not equal to 1. So let's have a look at some examples. This right here is a very, very nice rule or property, but it can be sometimes a little bit tricky to apply. So 5 raised to the 0 power, well, 5 is a real number. That is going to be equal to 1. 2 times x times y raised to the 0 power, if we assume that x and y all also are real numbers, then, well, what do we get? That will also be 1. And now here is the tricky part. Parentheses make a difference. 2 times x times y to the 0 power, the only factor that has 0 as a power is y. So in other words, there are exponents that we don't write attached to the 2 and the x. We do not need to write 2 raised to the 1 times x raised to the 1 times y raised to the 0. But what happens right here is that the 2 stays, because 2 to the 1 is just 2, x stays, and the y raised to the 0 power, that will be turning into 1. So in other words, short, this is going to be 2x. Parentheses make a difference. Now, the last one is probably the trickiest one of them all. We are inclined to say that negative 2 raised to the 0 power is also 1, because negative 2 is a real number. But you have to look at it in this way. A negative 2 raised to the 0 power, this negative is not part of your base, the one that gets the exponent. So in other words, this is the same thing as if I write it like this. And if I write it like this, then you see that all of a sudden 2 raised to the 0 power is 1, but this negative in front is just going to turn this into negative 1. So not like this. A negative 2 in parentheses raised to the 0 power, that will still be positive 1. Here is the quotient rule. So we are slowly building the things up that we are raising to some powers. What if I have inside my parentheses a little bit more, a quotient? Then what happens is that this exponent up on the top right corner basically just jumps to the top and to the bottom. It kind of looks like distribution. It is not exactly the same. So I'm ending up with a raised to the n divided by b raised to the n. If we are looking at these two examples right here now, then what we are going to get, I have to first use my rule, and that will tell me that I have 2 raised to the third divided by x raised to the third. Placing parentheses is always the safest thing to do. And now 2 raised to the third power is not equal to 6. That would be 2 times 2 times 2, and that is 8. And on the bottom, I just have x raised to the third. Now the reason why I've placed parentheses in the first example, you see this now in the second one down here, I'm using the rule again. I have something in parentheses that is being raised to the third power, and that means now that I have the numerator raised to the third power divided by the denominator raised to the third power. And we have seen already rules in the section before that apply to these scenarios. This right here now, I have to multiply my exponents, and I will get x raised to the 6th divided by y raised to the 12th. So there are really 3 things that I can do with exponents. I can add them, I can subtract them, and I can multiply them. And it is your job to know when to do what. Let's have a look at another example, slightly bigger. We want to simplify 5x to the 4th divided by y squared, everything raised to the third power. So I'm slowly now starting to use all of my rules. The first rule now that I'm going to apply is that there are some parentheses. I have an exponent of 3 on the outside, and that means that my numerator, 5x to the 4th, will be raised to the third power. You see, these parentheses are going to be very important later on and already right now. Now, in the numerator, I see I have now a second rule. That was when the exponent jumps to both factors. Remember this one right here from the last section? A times b raised to the n is a to the n times b raised to the n. And that's the rule that we have to use here. So we are going to get 5 raised to the third, x to the 4th raised to the third. And in the denominator, I'm already going to do this. This is y raised to the 2 times 3. So 5 raised to the third power is 5 times 5 times 5, and that is 25 times 5, which is 125. 125, I have my rule from before, 4 times 3 divided by y raised to the 6th, and I have the final result, 125 times x raised to the 12th power divided by y raised to the 6th power. Now let's start to divide monomials. If I divide monomials, I am looking at the numbers, the coefficients separately and the variable parts. For the variable parts, I will just use my rules. The numbers, I just divide. In other words, I will simplify those. So let's have a look at this example right here. We are supposed to divide 5x to the 7th divided by 10x cubed. So here's how I am allowed to think about this. This is 5 over 10 times x to the 7th divided by x to the 3rd. This is all multiplication. This can be split into two pieces. Now, 5 over 10, this can be simplified. This is the same thing as 1 over 2. 5 and 10 both have a factor of 5. And x to the 7 divided by x to the 3rd is just x to the 7 minus 3. So I will get 1/2 times x to the 4th. I can rewrite this if I wanted to. I can introduce the number in front back in. X to the 4th divided by 2. These two expressions are identical. Sometimes I like to write it more like this, without the dot in between, to see what the coefficient is. But strictly speaking, this is the exact same thing as this. Let's do a bigger one yet. So we have 9x to the 6y to the 5th. We want to divide all of this by 3xy squared. So the way that we are doing this, I will be looking at the numbers. Then I have x's in the top and x's in the bottom. So I have x to the 6th divided by x to the 1st. Multiply this by y to the 5th divided by y to the 2nd. And now I'm using my rules with the numbers, of course. I'm just dividing. 9 divided by 3, that will be 3. And x to the 6th divided by x to the 1 is x to the 6 minus 1. Multiply this by y to the 5 minus 2. And now I'm just cleaning up everything. I will get 3x raised to the 5th times y raised to the 3rd. And that is it. Notice that at the moment, the numbers in the numerator, the exponents, were always bigger than the numbers in the denominator. And that means that at the moment, when I do this operation, top minus bottom was always positive at the moment. This will change in the next section. Top minus bottom. The rule will never change. The rule is always the same. Let's have a look at some bigger division problems. This follows the same pattern as when you learned division at first. You first start to divide small numbers, and then you start dividing bigger numbers. So we are dividing now a polynomial that is not a monomial by a monomial at first. So let me give you an example with numbers. The system of the polynomials are analogous to the system of integers. So I can always give you an example with numbers, integers, that apply to polynomials as well. You have seen this already. I can do the same thing with polynomials that I can do with integers. I can add them, subtract them, multiply, and divide them. So if I have a problem like this, 12 plus 9 plus 6, and I divide all of this by 3, then what I am allowed to do here, I do not even need to do the operation in the numerator first. I can break this up into 3 separate problems like this. Everything gets divided by 3. This was the definition for addition of fractions. They have the same denominator. That means I just add the numerators. Of course, I can always go in this direction because this is equal to each other. And you see why this is fairly handy in this case, because 12 divided by 3 is just 4. plus 9 divided by 3, that would be 3, plus 6 divided by 3, that is 2, and at that moment what I would get is 4 plus 3 plus 2. Let's see, that would be 6 plus 3, that would be 9. This is the same thing that we are going to be doing with our polynomials that I will divide by monomials. Let's do an example. I want to divide 5x to the 6th plus 2x to the 4th minus 10x squared, all divided by 10x. Notice the thing in the top right here is not a monomial. Monomial meaning one term. I have addition and subtraction. I have 1, 2, I have 3 terms all together. Actually, this is called a trinomial. But what I will do now is the exact same thing that I have done with my integer example just a second ago. I will turn this one big problem into 3 smaller problems, and I will then have something that I can work with. So in other words, every single thing gets divided by 10x. You take the big problem and you turn it into 3 small problems. This is something that we always like to do in math. So these kind of problems by themselves, something like this here, whoops, now I lost half of my problem, something like this, we have just done a moment ago. A monomial divided by another monomial. So we have taken the big problem right here and we turned it into 3 problems over here that we know already how to do. Let's have a look. The first one is going to be 5 divided by 10 times x to the 6 minus 1. Remember, the exponent at the x in the denominator is 1. Plus 2 divided by 10 times x to the 4 minus 1. Minus 10 divided by 10 times x to the 2 minus 1. And now I just simplify all of this and clean this all up. 5 divided by 10, that is 1/2. X to the 6 minus 1 is 5. Plus 2 divided by 10 is 1/5. Times x to the 4 minus 1 is 3. Minus 10 divided by 10 is 1. I do not need to write in a coefficient of 1. And 2 minus 1 is 1 as well. This one and this one up front right here, we do not need to write. So it's just going to be negative x. This part right here turns into negative x. Again, 10 divided by 10 is 1. 2 minus 1 is 1 as well. Minus 1x. And I can now, if I wanted to, write this as one fraction, 1/2 times x to the 5th. That is the same thing as x to the 5th divided by 2. Plus x to the 3rd divided by 5 minus x. On the homework examples, it doesn't matter. Both of these answer choices would be the same. This is the same thing as this and vice versa.